In this section, we're going to review the tools and techniques for performing schedule development. The tools and techniques will include the schedule network analysis, the critical path method, the schedule compression, the what-if scenario analysis, resource leveling, the critical chain method, project management software, applying calendars, adjusting leads and lags, and the schedule model. The schedule network analysis produces the project schedule. It calculates early and late start dates and early and late finish dates for activities. It uses the schedule model, and it uses analytical techniques such as critical path and critical chain method, what-if analysis, and resource leveling to calculate the dates. It's performed without taking resource limitations into consideration, and it establishes time periods within which activities can be scheduled. Limitations and other constraints are taken into account later in this process. The critical path method is another type of schedule network analysis technique. It determines the amount of float or schedule flexibility for each of the network paths by calculating the earliest start date, the latest start date, and the latest finish date for each activity. It relies on sequential networks on a single duration estimate for each activity, and it determines schedule durations without regard to resource availability. The critical path is generally the longest full path on the project, and activities with a float time equal to 0 are typically considered a critical path task. If an activity uses up all of its float time, it becomes a critical path task. Milestones with a finish no later than constraint to them can change the critical path if they are not met. Float time is the same as slack time, and there's two types of float. The first is total float, which is the amount of time the start of a task can be delayed without delaying the ending of the project. And free float. This is the amount of time the start of a task can be delayed without delaying the earliest start of a successor task. Here's an example of how the critical path duration is calculated. Across the top of this table, you'll see the task, preceding activity, and the estimate to complete in weeks. Down the left side, you have the activities listed. Note that Activity 3 is dependent upon Activity 1 to be completed before it can begin, and Activity 4 cannot begin until Activity 3 is completed. Therefore, the critical path duration is calculated by adding Activities 1, 3, and 4. When you add those together, you have a total of 16 weeks, so your critical path duration here is 16 weeks. This is a diagram of essentially the same calculation, except it's in a graphical form. You can note that Activity 3 is still dependent on Activity 1 being completed before it can begin, and you see Activity 4 follows Activity 3. The calculation is the same in that you add together Activity 1, 3, and 4 to get 16 weeks. Activity 2 is only 8 weeks long. Therefore, the longest path is 16 weeks and is therefore the critical path. This concludes the critical path method explanations. We're going to continue with tools and techniques in the next section.